hypothesis testing, the liar test. So it looks like I have two tests here. The first one says it has been reported the mean amount, so I think that's going to be the mean test. And this one down here is a proportion, so I think that's going to be my proportion test. All right, so what I kind of do is I kind of pick apart the pieces. So I'm going to do the mean first. And the very first, I'll never forget when I took this course, it wasn't that long ago, so stop making jokes. Is my teacher always said, draw a picture, draw a picture, draw a picture. And I'm like, I don't know what you want me to draw a picture of. Well, if I'm looking at this mean amount, they are telling me, if I have this t distribution, that they are telling me that an individual, an adult, receives 7 hours of sleep per night. That is the null hypothesis. That is the null hypothesis. I didn't mean to jump that far. I wanted to jump up a little bit. All right. So that's what they're telling me. Would you go back up a little bit? There we go. All right. You go out and you do a study where that is your sample size, 49, and you get 6.2 hours. And what you want to do, and a standard deviation of 1.8, you want to check with this significance, do you believe they're really getting 7 hours? Now, Cindy's not going to do this exact problem for you because then you'd be like, oh, you're so nice. So I'm going to do something, and I'm going to say, I think on average, people are getting 8 hours of sleep. All right, so that is my null. I'm going to say that I went out and I sampled, I don't know, let's say 80 people. All right, I got a bigger sample. And when I went out and I sampled, I found out on my sample, I added up all the average number, the number of hours they got sleep, and then I added those up and divided by 80 to get the average. And let's say I got 7.3. All right, let's say my standard deviation, this I got. Okay, I can leave that the same. That doesn't matter. The 1.8 hours. All right, what I want to know is 7.3 statistically significance level too far away from that mean. Well, the problem is unless you can look up in every book in the world for go find an 8 average with this, what we have to do is we have to standardize our data, and standardizing says that's a 0. What is this value? I'm so happy you asked. How we find this value is we find the test statistic, which is equal, please put the top in parentheses, my sample mean minus the null that they're telling me to believe, close parentheses on the top, divided by, open parentheses for the bottom, my standard deviation divided by the square root of my sample size, close and close. All right, so I hit enter, and this is my standardized, negative right there, my standardized test statistic, which says I am 3 standard deviations away from that standardized mean. Now what we want to know, is that too far? And what is too far? Well, too far would be if I got a critical value here, and I can use a formula, t.inv, and formula is so nice. It wants my probability by significance level, my degrees of freedom, which is my sample size minus 1. What I want to know is, does this fall, does my negative 3.48 fall in the critical region? Oh, wow, yeah, buddy. Because it looks like, if I get another color here, it looks like the critical region, so that's 3.4, is like right here, right? -1, and I probably should put this a little lower so you realize we're down here in the standardized. So -1.664. So I definitely fell. This is my critical region, and I am in it. Another thing that you can also check is, remember, if the P is low, the null must go. If the P is high, the null will fly. Check the p-value. The p-value is the probability, and we do that here, that we believe the null with the t.dist. It tells me what I want. Don't get confused. It says x, but what it wants, x is your test statistic, and then your degrees of freedom, which is just your sample size minus 1, and I want it to add up all this area. Basically what this has given me is what is the probability if they are really getting 8 hours, what's the probability I would expect to have a sample of 7.3? Ooh, look at that baby. That baby's low. So in other words, that's this area right here. This is saying I really would not expect, if people are really getting 8 hours, I don't know why I can't say that. If people on average are getting 8 hours a night of sleep, based on my sample, no they're not, because it's way too low. All right, very quickly look through the proportion test. So how do I know this is a proportion, the 0.383? Please be careful that you put this in decimal, so 0.383. All right, and then it says here, let me kind of go through and read some of this. I gathered 32 adults. I found 15 received at least 7 hours. You're doing the same thing, but it's a proportion now. All right, I'm going to put some different numbers in here. So in other words, where it says 32 adults, heck, we'll stay with my 80 sample size. 15 out of 32, so I'm going to say 42 out of 80 actually got at least that number of hours sleep. How do I get the sample proportion? The number that said they got that divided by the total sample. And now this one now is I'm looking at a Z statistic. All right, this was a T. Proportions always use Z. This used a T because we did not know the population standard deviation. All right, and so now here I can find the Z value, which equals, top in parentheses, P hat, that's my sample proportion, minus my population proportion, divided by, now this you don't have to put in parentheses because the square root's going to put it all in parentheses, but I want to put the top in parentheses, which is P times Q. What the heck is Q? Well, Q is just 1 minus P. So I could put that in parentheses, 1 minus P, or you could have had it over here in another cell. I've already lost all my parentheses. That closes the top, divided by the sample size, close my square root. So nicely Excel color codes these parentheses. So the square root of the null proportion times 1 minus, that's the Q, P, and then divided by my sample size. I hit enter, and this gives me my Z value. So now from here, notice it says the claim is that more than. Sorry, I'm starting to cough. So I didn't really write this out on this one down here, but I probably should have. This is a null hypothesis. I'm going to write mine. Well, mine's going to be, no, yours is 7, yeah. So my null was 8, and then my alternative was that the null was less than 8. All right? So up here, I'm saying at least 7 hours. So my null is a proportion, and I'm saying that proportion here, okay, so the claim is more than 38 point, whatever that number is, that. But now I'm looking at more than. So this alternative is going to be a greater than. If you remember, when we do greater than, we have to do 1 minus the probabilities. All right, let's do it. So this would be my norm.s.dist. It wants my Z value, and yes, I want it to accumulate it. So that's the p-value. And you're like, wow, that's a high p-value. Well, that's less than. I want to match my alternative, which is 1 minus that value. My p-value is definitely less than my level of significance, which once again, I could find a critical value, but I got to be careful. This critical value is going to be 1 minus, because it's a greater than, norm.s.inv, because I'm standardizing. I'm looking at my probability. I close my parentheses, and this is going to give me my critical value. Does this value right here fall in this critical region? Okay, 2.61. And so what I can see is it looks like, Okay, so based off of all my values here, it looks like my p-value, all right, it looks like my p-value, what's going on here? Well, silly Cindy didn't read the question. This one's a 0.01. Okay, so be sure you change your significance level to the right significance level that's given to you. So looking at this, the p-value, the p is low, the null must go, meaning that I don't believe this proportion is correct. Also, my test statistic did fall in that critical region. So that's the kind of things that you're looking at. And again, I think the best way is to draw this out as a picture. You can do the same thing up here. You can draw this out. Right down the middle is the 0.383. I want to see if this proportion, okay, based off of this, the 0.525 is way higher than that value. And I mean, you can play around with these values because now that you have these formulas in here, all I have to do is change these numbers. So let's say I change that to 38. Ooh, getting closer. Let's say I change that to 35. Now notice my p-value. First of all, notice my test statistic does not fall in the critical region. Notice my p-value is greater than 0.01. So in this case, if I got this, I would fail to reject and I would have to go with the null. All right, that's all, folks.